So I'm going to tell you which characteristics are going to be on each of them. And you know how the test in the study guide, I call them like a sibling problem, like the ones that are similar. The one that is similar to number 1, you're going to do the vertical asymptote, the horizontal or slant asymptote, the hole, and the end behaviors. That's it. I won't make you draw a graph. Like, I'm just picking and choosing certain characteristics, and I'm trying to be very upfront with you about which ones they're going to be. Okay, so that you know what to study. For number 2, it's going to be the x-intercept, the y-intercept, and the vertical asymptote. The one that's similar to, like the sibling problem to number 2. Those are the characteristics I'm going to ask. For number 3, it's going to be the domain, the vertical asymptote, the horizontal or slant asymptote, and the end behaviors. All right, for 4 and 5, it is going to be all of them. So there's only 2 of them that you're going to do the whole everything. It'll be like your quiz 2.0, where you'll do the graph and you'll do the entire list. So only 2 of them, not all 6. And then this one is going to be the domain, the x-intercept, the y-intercept, and the hole. So again, I'm just trying to be very transparent with you about what is going to be on the test, so that you don't like stress yourself out about stuff that's not even going to be on there. Okay. So here's what we will do for the front half of this. I'm going to let you guys pick 3 of them. And I think one of your 3 should be like one of the all ones, like either 4 or 5 should be one of the ones you guys pick. But I'll do 3 of them, and I'll leave the other 3 for you. The answers are all on Schoology, so you can try them on your own and check the answers, but we'll pick 3. So what do you guys want to start with? Number 4. So we are going to start with number 4. Let me zoom out a little bit. And we're going to need to factor that. So how is that going to split? It'll be x minus 3, good. And then x plus 2. Now, it's very tempting to make it cancel out, but it doesn't. X plus 2 and x minus 2 will not cancel. It has to be the exact same. Okay? So I would start with domain. Who is your troublemaker that's going to get not invited to the domain party? 2. Kick out 2. 2 is a problem. So once you kick 2 out, what are the things that 2 could become? Yeah, either a hole or a vertical asymptote. It can't be both. You can get both of those in a graph. That's if you have 2 troublemakers. One of them would be one of them would be the other. But if all we've got is 2, it can't be both. So which one is it going to be? Good. And why is it the vertical asymptote and not the hole? Yeah, nothing canceled out. Okay. Now here's my suggestion. As soon as you figure something out, go and put it on the grid. On the test, obviously, this will all be printed on there for you. Okay, like there will be a grid, there will be a list with all the things, exactly like it was on the quiz. Don't like try to be so much of a perfectionist with your graph. You don't have a grid right now, so it won't be perfect. It's okay. The next thing I would suggest doing is the horizontal or slant asymptote. We're going to go back and look at the powers on the original problem. So I'm pointing right here. The numerator's squared, the denominator's just x. So if the numerator is bigger than the denominator, do you remember which one that was? Yeah, that's your synthetic division. It's the slant asymptote. So we're going to get a slant asymptote for this one. Our troublemaker was 2. That goes in the little box. And then what are your coefficients from the problem? Good. 1, -1, -6. And the remainder won't necessarily be 0. It will not be 0. We don't use the remainders anyway. And that should hopefully be like a quick, easy division. Just what we did last unit, except way shorter. Did you get 1, 1, -4? Confirmation? Okay. So we throw this out. And the way you write your answer is y = mx + b, good old slope-intercept form. And so it would be y equals, now it's kind of weird because they're both 1, but it'll be y equals 1x plus 1. And when you dot that in, you're going to start at 1. So we're going to start right here. And then do a slope of 1. So it's up 1 over 1. And again, it will not be perfect on here without a grid. So just, you know, don't expect too much from yourselves. It's good enough. It is good enough. Now that is all great, but everything we have on there so far is invisible. So where did I make the suggestion you go from there? Like, what should we do next so we have actual stuff? Yeah, good. Your intercepts. So x-intercept, you're going to set the whole thing equal to 0. Just this whole thing equals 0. So what would you do to start solving? Yeah, you would multiply the denominator over, that's going to go away. And so actually we're going to get 2 x-intercepts. If you set these factors equal to 0, what are you going to get? Yeah, good. -2 and +3. So we get -2, 0, +3, 0. And so you can put both of those on your grid. So again, as soon as you find something, go put it on the grid. How do you get the y-intercept? Set all the x's to 0. You're going to plug in 0. You can either plug into the factored version or the original one. It's not going to make a difference. I usually say the original one is a bit easier because you can just cover up all the x's. You're left with what? Yeah, -6 over -2, which would be +3. And again, if you plugged into the factored one, you'd get the same thing. So it really doesn't make a difference. You just plug in 0. So 0, 3 would be right here. And then you can just connect it all. You go through the points that you have plotted and just don't run into the asymptotes. So it's going to be like this. It doesn't look great. Mine doesn't look great either. To be really honest, on the test, even when you have a grid, it's not going to look great because these graphs just look weird. So you got to just kind of accept that and not let it be a big deal. Does anyone remember what the other things are? You don't have to have them memorized. I'm just throwing the question out there. What are the last 3 things that we didn't do yet? All right, range and the ends. And I think I heard somebody say the other one. Yep, good, perfect. Increasing, decreasing. So I'm just going to set up all those things. You don't have to have that memorized. Like, again, it'll be printed on your test. I was just throwing the question out there, but you guys are on top of it. You guys make my life easy. Everyone like listens and knows what's going on. It's fantastic. You guys are wonderful. And the range is kind of nice for this one. As you sweep downwards to upwards, what do you get? Yeah, all reals. It's everything. Like you get all of it. One of these will say none. So one or the other. As you read left to right, what is it doing? It is increasing. So decreasing is none. And the answer is actually already written there. What answer do you copy over for increase? Domain. Perfect, because it is left to right. So you copy that over. And then end behavior. Usually it's a number, like usually it levels off somewhere, but this one's a little bit different. If you cover up the middle of the graph, where does the left end go? Negative infinity, and then the right end, positive infinity. So if you have a slant asymptote, it doesn't level off at a number. It's going to either go up or down. All right, so we're going to look at number 5. So I'm just going to write right above here on number 5. You have 3x squared plus 9x minus 12. What can you divide out of all 3 of them? 3. So I'm just going to write right above there. When you divide out 3, you'll have x squared plus 3x minus 4. The reason I wrote it on there is because it's a 2-step factoring problem, and I was trying to avoid having to write the whole problem over again. Again, I'm just trying to save you some work. All right, so on my scratch paper here, we'll do the next step. We're going to keep that 3 and just split up the rest of that. So how would that break apart? Yep, good. +4 -1. And then the denominator is going to be x and x. And how would that one break apart? Good, perfect. -3 -1. So how many troublemakers do we have in this one? 2. They would be 3 and 1. But when we write it, you have to go smallest to biggest. So for your domain, you're going to skip over 1 and then skip over 3. I don't see that as a mistake too often. Most people remember to do smallest to biggest. That's usually pretty good. All right, so then once we kick those out, the things they can become are the whole or the vertical asymptote. So one is going to be one and one is going to be the other. So which one's going to be the whole? Yeah, one will be the whole. And so 3 would be the vertical asymptote. So again, it's not going to look perfect on here. You'll just need to accept that. On the test, you'll have a grid. But I would go ahead and dot that in at 3. See, mine's like all wonky. It's fine. It's like good enough. Then you want to go back and get the other part of the whole. You're just going to take 1 and plug it into what's left here. So we're plugging into this part. So 1 + 4 would be 5 times 3, 15. And then 1 - 3 be -2. So -15 halves. Now, when you go to put that on the graph, you have to know like where that's going to be. It's going to be negative something and a half. So -7.5. So at 1, -7.5, which would be like right about there. Again, it's not going to be perfect. You just have to accept that. Just keep saying that as a pep talk. Because I know some people are like really perfectionist and want it to look great. It's like, these aren't going to look great. All right, what thing do we want to do next? Like what characteristic do you want to go to next? Yeah, horizontal or slant asymptote. Get the other one. So if you look back at the powers in the original problem, what do you notice about them? They're the same. That means you're going to use coefficients. 3/1, which would be 3. So your horizontal asymptote is y = 3. As an extension question, because we did one that was slant. We did this one where we used the coefficients. If your numerator power is smaller than the denominator, what is it? 0. It's going to automatically be 0. Okay. So we're going to dot this in at 3. You can dot it in the whole way across if you want, but it's technically just the edges. All right, cool. That's all great, but it's invisible. So where should we go next? Yeah, x and y intercepts, because that'll give you an actual point to plot on the thing. And then you can connect it all. After you get done with that, you can connect it. So x, if you set this equal to 0, the denominator is going to go away. This is gone. 0 divided by 3 is 0. So all that's gone. What do you get? Yep, -4. That's the nice thing about 0. It makes pretty much everything go away. So that would be right here. And then y-intercept, you're going to plug in 0. And again, I sometimes find it easier to use the original one for that because you can just cover up all the x's. If I cover them all up, what am I left with? Yeah, -12/3, which would be -4. So actually, weirdly, they're the same thing. Or not weirdly. I mean, a lot of math things have symmetry. So, all right. So then you can just connect everything. It's going to look something like that. Again, it's not going to be perfect. Just go with it. And then again, it'll be printed on the test, so you don't have to memorize this. But you guys did remember when I asked you before, what are the other things? Like, what did we not do yet? Yeah, increasing, decreasing, range, and then the ends. Okay, so you guys even know the list. That's awesome. You don't have to know that though. Again, it'll be printed on the test. So as you read left to right, what is this graph doing? Decreasing. So increasing is none. Decreasing, you're gonna copy over domain. Good. If your domain is incorrect, but you copy it over, I give you credit for the decreasing. One of them is gonna be none. Now, that's not true for all graphs, but if there would be like both of them, I just don't ask it because it gets too complicated. So the one I ask you, if one of the other will be none. All right, and then range, you're gonna sweep downwards to upwards. So who's gonna get left out of the range? Yeah, that -7.5, so we're gonna skip over -15 halves. And then why 3? Because that's correct. It's your horizontal asymptote, so it won't touch that. Those are the things that are missing. And then where are both ends leveling off? At 3. They won't touch 3, it's just where they're headed. It's just behavior. So I said I would do one more from the front. I'll pick because I know where the common mistakes are. And I'd like for us to do number 2. So if you could all look at number 2, we're gonna factor that first. So what can you factor out of the numerator for number 2? You can take out 4. And so if you factor out 4, you'll be left with x minus 2. And then the denominator is going to split into what? Good. So what do you notice happens there? These cancel. That means there would be a hole, but did I ask you for the hole on this one? No, and I think that's what trips people up on this one. So what I did ask you for was the x-intercept, the y-intercept, and the vertical asymptote. I would start with the vertical asymptote. This is all gone. Who's your other troublemaker? 4. So your vertical asymptote is going to be x equals 4. And to get the x-intercept, you would set this equal to 0. The denominator would go away, and so what you end up with is 4 equals 0. And then people write 4. Does 4 equal 0? No. So that means what? None. You will not have one. That's the common mistake. And I get why it happens. That's why I'm going over. All right, and then y-intercept, you're going to plug in 0 for x. So if you plug in 0 for x, you get 4 over -4, which would be -1. So we did the majority of the front of this. I did 3 of them, and I did the ones that were everything. So all you would have left is 1, 3, and 6. The answers are on Schoology. You don't have homework before a test, so please do them, check your answers. That's how you study. If you're curious about how you study for math, you study by doing problems, okay? And then I'll do one more on this side. I'm assuming probably everyone would want me to do the word problem. Is that a like fair assumption? Okay, we'll do the word problem because we already did this one and we did the number line one. As a heads up, because somebody asked me yesterday, for number 11, I'm not going to do the whole problem, but do you get that the numerator would split and the denominator would split? You would have 4 number lines. Okay, you'd have 4 number lines, but they would all be like straightforward. All right, but we'll do number 10. Number 10 says the sum. All right, what does sum mean? Adding. So look, if you want to set it up, you're going to have something plus something equals something. If that helps you to just have blanks there, like, hey, we're going to add 2 things together, and then you can just kind of fill it in. So it says the sum of 3 times a number. How would you put 3 times a number? 3x. And then it says twice. Okay, that's 2 times something. And then it says the reciprocal of the number. The reciprocal of 7 would be 1/7. The reciprocal of 10 would be 1/10. So like the reciprocal of the number is like, yeah, 1x, like 1 over x is 5.
2 times 1 over x is
2 over x, yes, that comes down to personal preference. All right, we're gonna multiply by the common denominator. What's the only thing that's in a denominator? Yeah, x. So you're gonna multiply everything by x. The point being you want it to cancel. That's like why we do that, is to make it cancel out. You want the fractions to go away. So what do you have for this first one? 3x squared plus 2 times 1 is 2 equals 5 times x is just 5x. And then where do you go from there? We got all the fractions to go away. That's good. Evacuate. Good. Minus over the 5x. Sorry, I wrote that kind of quick, so I was trying to pause, make sure everybody's with me. All right, and then we're going to factor it. So how would you split 3x squared? Because it won't just be x and x now. It's a little harder. Yeah, 3x and 1x. 2 is going to have to be 2 and 1. And then, yeah, they're both subtract, right? Because it would be minus 3x and minus 2x. All right, and so your answers would be what? 2 over 3, and then 1. Your troublemaker was 0. We did not get 0, so we're good.